The center of some data is a nice value to look at as it can summarize the set. There are a few centers to data that we can use: the mean, median, and mode. The mean, the mean is also called the arithmetic mean, is typically the most common center we use. It's very useful in a lot of other applications as well. To find the mean, all we have to do is add all the numbers together and then divide by how many numbers there are. So for this first set here, there's 1, 2, 3, 4, 5, 6, 7 numbers total. All I have to do is add them all up and then divide by 7. Doing this on a calculator, let's see, 2 plus 6 plus 15 plus 3 plus 1 plus 8 and 7 gives us 42. Divided by 7 gives us 6. So the center, or the mean in this set of data is 6. The same thing is true for the rest of them. There's 5 in this set. We're going to divide this by 5. 34 plus 57, 68, 12 and 9. Divided by 5, this gives us 36. And then the last one here, 40 and 80, you don't have to do the actual addition and divide by, like in this case we would add 40 and 80 and divide by 2. What's the number directly between 40 and 80? It's 60. So 60 should be our mean. If you were to add them up, you get 120, and 120 divided by 2 gives you 60. So really the mean is just saying, what's the number right in the middle of all of the numbers? A lot of times the mean is a decimal. It's not nice numbers like this, but in this case, they were all like that. Now the next measure of center is the median, which is also like actually the middle number. You have to arrange the set from greatest to least to find the median. So that's always the first step. If it's already arranged, then you just count in from both sides. So this first set here, it's not arranged. I'm going to arrange it. It's going to be 2, 3, 8, 17, and 21. Now, this is now arranged, so we're going to start from each side and count in one, in one. Now we're going to go in another one. And there you go. 8 is the median. In this next set, we have, this is already arranged, so we can immediately start counting in. So we start here, count in one, in another one, in another one. And now you see there's no center variable, or there's no center number. So what do? We find the mean between the middle two numbers. Well, you can already tell, I mean, hopefully you can tell that the mean is going to be 321. That's right in between 320 and 322. But you can just add the two numbers up. So 320 plus 322 and divide by 2. That's going to give you 321. So the median for this last set, right, we start here, and we go in one and in one. And you see that the median here is 26. Which is interesting because 15 and 26 are very close, and 1701 is very, very far away. I would call that an outlier. And that's where the centers don't necessarily, each center has issues with it. It doesn't necessarily tell you all the extent of the data. Median, for instance, is very susceptible to outliers. So just keep that in mind whenever you're working with the numbers. There are issues with each one, so that's the reason why there's a variety of them. Now the last type of center is called the mode, and this is the number that appears most often. Now, mode's a different kind of center value. It's saying the one that appears most is the center, but that only works for repeating sets. So in all the previous sets that we have here, none of the numbers repeat, and so there is no mode for any of these. But when you have what's considered like a frequency distribution, like how often something happens, that's where mode kind of shines the best. You can see in this first set here, 3 would be the mode because 3 appears the most, appears 4 times. 7 and 7 appeared twice, so it's 16 and 16, but 3 is 4 times, which is far greater. In the next set, the mode is going to be 95. That appears the most. And the last one, 3.2, is the mode. A frequency distribution is a chart of how often numbers in specific groups occur. We group the numbers into classes, and this is done because we typically have too many numbers to look at individually, and we group them so that we can see clearer trends. For instance, for this thing right here, for this problem that I have, to best determine the fuel economy of a particular car model, an automotive technician calculates the mean gas mileage for 20 full tanks of gas. We're going to use a frequency distribution to find the frequency mean of the following. And this set of numbers here are all the gas mileage for the 20 sets of gas that the technician found for the car. So because this really isn't that big of a set, and so you could do this by hand. I mean, a lot of times frequency distributions aren't used anyway because we have software to calculate all this stuff for us, which does it very quickly. But it can be useful occasionally. So that's why we're talking about it here. The first thing we're going to do to create a frequency distribution, that's what this table is down here. I'm going to show you how I gave it the values that are in it. The first thing we need to do is note what's the smallest and what's the largest value in the set. Looking at the set, I see 19.5 is the smallest, I do believe. And the largest looks to be this one, 25.6. Yep, 25.6 is the largest. Okay, now this data here says use classes of 1 mile per gallon, where 19.0 to 19.9 is the first class. That's the first class because that's where the smallest number appears. You could use a class value of 19.5 to 20.4, and then 20.5 to 21.4. You could do that. This is just how the problem is suggesting it handle out. But if this is going to be our first class, that means we just continue on up making the classes. And this last class here is our last class because it contains the highest value number. So that's where we're going to stop. Okay, now that we have our classes, we can start populating the frequency. So for the first one here, 19.0 to 19.9, all I'm going to do is count how many numbers fall within that range. We have 1, 2, and 3. So the frequency is 3 because there's 3 numbers that fall in the range. For the next one, let me do it in blue here. We're going to do 20.0 to 20.9. We have 1, 2, 3, 4, 5, and that's it. And the frequency there is 5. So it's the same process all the way down to the last class, 25 to 25.9. Okay, so that's how we populate those fields for the frequency. And n equals, n is just how many numbers did you add up. You can either add up all the frequency or just count how many numbers are in our set. And there should be 20. Yeah, because it says the gas mileage for 20 full tanks of gas. But you can just count the numbers up and you'll see there's 20 of them there. So n equals 20. That's going to be important for later. Now the midpoint, this column here, the midpoint is always the mean of each of the classes. This is always going to be the same type of number. As you can see, 19.45, 20.45, 21.45. That's because the classes only go up by 1 each time. And to find the midpoint, you just take the highest minus the lowest, or the last and the first, and just add them up and then divide by how many there are. In this case, there's 2, so we get 19.45. That's just all the work that I showed here. That's the midpoint. It's the midpoint of the class, not the actual data that you're given. And the reason why we do that is because we've now converted the data we've had into nicer numbers. And these nicer numbers, we know everything about them because they don't vary at all. They're very set. Whereas the data numbers, they change frequently. They're very different. Like 21.7 to 19.5, like that's a big change. It's kind of weird. So the frequency distribution helps keep things just nicer to work with. Okay, so that's the midpoint. Finally, the product is just the frequency times the midpoint. So for this first one here, the frequency is 3. The midpoint is 19.45. And 3 times 19.45 is 58.35. For the next one, we have a frequency of 5 times the midpoint of 20.45. And that gives us 102.25. And so on and so forth for the rest of them. This sum here, that's kind of the main point we're trying to get to, is this sum. And this sum is just all the products added together. So you just go straight down, add all these up, and that gives us the sum here. Now, this is where the main point of this whole thing is. We take the sum and we divide it by how many numbers there are, in this case 20. And this gives us 22.17 mpg. So for the frequency distribution, we have a frequency mean of 22.17 miles per gallon. Now, if you were to actually plug these numbers in into a calculator and find the average, what you're going to find is the actual is 22.15. So it's very close, very, very close. That's the reason why we do this. If we have very large sets, like, you know, way larger than 20, like think like 1,000 or 10,000, it can be easier to work with a frequency distribution rather than just the raw numbers. Now, as a kind of a final question, at 270 per gallon, use the mean fuel economy to calculate the average cost per mile to operate the vehicle. So if we have gas costing 270, what's the average cost for gasoline for a full tank? Well, we have 22.17 miles per gallon, and we have $270 per gallon. What we're trying to do is we're trying to get dollars. It's the cost per mile. What we're trying to do is we want dollars per mile. And we have 22.17 miles per 1 gallon. Well, we have two unity fractions here. And we want this. So we want dollars on top. We're going to go 270 over 1 gallon. So this is 1 gallon. Times 1 gallon over 22.17 dollars. Or sorry, this is miles. And you see the gallons cancel, and we have dollars on top per 22.17 miles on bottom. And that gives us dollars per miles, which is what we want. So we just put that in the calculator. And that gives us the average cost for a single mile of driving this is about 12 cents.